Alright, welcome back to the Pewaukee YouTube channel. In this video, I'm going to go over problem 485 on Leetcode, and that is assign cookies. So we're going to try and do this using a standard algorithmic problem solving approach. So let's get into let's read the problem first. Let's get into step one. So step one asks, what is the problem really saying or asking me to do? So the problem is asking me to find the maximum number of children, or we'll say G elements, that receive a cookie which satisfies their greed value. So if you read the question, you can kind of get at this idea. It's not too difficult to understand what's happening here. So now let's take a look at step two. Step two is draw/evaluate examples and try to find patterns. So we're going to use a couple examples. Let's use different examples than what we're given. So example one, let's say G equals 6, 8, and 4. Okay, and let's say S equals 1, 7, let's say 9, and then 2, for example, something random. So basically, we need to find out how many children in this G list are going to be satisfied. So if we see 6, then that can give me 7. 7 is greater than 6, and then 8 is greater than 9. So 2 children are going to be satisfied. 2 children. So result equals 2. Let's do a different example. Let's try and get a little bit more complicated here. So let's say G equals 2, 9, and 10. Let's say S equals 12, 11, and 7. Or let's say, actually not, let's say something like, I'm trying to get a certain evaluation here. Let's say S equals 12, 10, and 7. Okay. So we want to find the maximum number of children for this one. So if we say, okay, 12 is greater than 2, and then 10 is greater than 9, and 7 is greater than 10. Oh wait, oh yeah, this is fine actually. I think what I wanted to say was, let's say there's only 12. No, I don't know if that makes sense. Well, let's just roll with this for now. So we have 12 is greater than 2, 10 is greater than 9, but 7 is not greater than 10, so again, 2 children. I'm thinking about a case where you would initially try and solve the problem, but you wouldn't actually get the maximum solution. That's what I'm trying to think about. What would that solution be? Or what would that example be? Let's try and think of another example. And let's say G equals, I don't know, let's think. What if we said 9, 10, or not, let's just say instead, you had G equals 2, 1, let's say 1, 4, and then S equals, let's say this was 3 instead. I'm trying to find if there's like some type of weird case. So let's say S is 4, maybe? Oh, okay, I have an idea. Let's say 4, 2, 1. Does that make sense? Yes. So let's think about this, right? So 4 is greater than 3. That's great. 2 is greater than 1. Okay, that's great. 1 is not greater than 4, however. So that's not going to quite work if we kind of examine it linearly. But can we find, so that would be 2 children, but can we find a solution where there's 3 children satisfied? And the answer is no. Okay. Okay, what if this was 4 instead? If this was 4. Then we would say, okay, 4 is greater than 3. And then again, 4 is greater than 1, but 1 is not greater than 4. But you can satisfy all children in the sense that 1 is equal to 1, 4 is equal to 4, and 4 is greater than 3. So the maximum amount would be 3. So we could say, in some cases, it is enough to iterate through the list. However, oops, that is not how you spell however. However, in other cases, this does not suffice. Not suffice. Okay. So you think of example 3, right? We tried to loop through it, but the greed factors could be more evenly matched up. So what I'm thinking is I could use a sort method. That's a general idea we could have. So we could just make a note. Well, technically the third step, try and make observations for the solution. Make observations to consider for the solution. All right. And so an observation could be that, okay, what do I think? Sorting could be a possibility. So we could say using sort, sort. Could we say, I think we need to use sort on both lists, in order to kind of match up the greed value with the child. Would that make sense? I believe so. So if we use sort for both lists, let's try example 3. If we use sort for both lists, we would get 1, 3, 4. We get 1, 4, 4. So that would return the maximum value, and then if we then did it by loop, or by looping. I guess the only problem with that is that I think it would be like the time complexity. I guess if it's only sort, then it's n log n would be the fastest sort, probably quick sort, even by using Python, which is what we're going to be using today. So I think it should be fine. So you know what? Let's try that as a solution. So let's say Then we want to say step 4. Break down problem. Break down the problem into the smallest steps possible. So let us try and find those steps. Let me move this a little bit. Alright, so step 1 would be to sort both the list. Sort both the lists. Okay, and then step 2, let's think. Step 2 might be something like, could go iteratively, something like that. Go through the list iterally. I think I'm just still saying that wrong, but go through the list iterally and see, or I guess before this would be go through the list so long as there's elements in both lists. So maybe we could use an index, throwing an index there and see if or I guess technically could use a while loop. Could be something. So let's write while loop here. While loop. Because if we sort and then we think about these lists, so long as the first cookie does not satisfy the first person, then we don't move on until a cookie satisfies that person. So that's why we use a while loop to iterate through. I think that makes a bit more sense. And then what we can do, so we'll just go through the list iteratively. That makes sense, iteratively. Yes. Stay at the first child until they are given a cookie. Yep, believe that makes sense. Stay at the first child until they get a cookie. And then when that child receives a cookie, yep, then we can increment a counter. So we do want a counter. Assign a counter var to 0. Okay. Stay at the first child until they are given a cookie, then move on. Then, or we'll say meeting the greed factor. And then we'll say step 3. Increment the index of the child list. Also, it might be better to set variables for both indexes. So let's say as well. So let's say step 1 here. Step 1 as well. Let's say set index variables. Okay. So now let's try and convert these steps into code. That's the last step. Convert the steps into code. So let's take a look at that. here. Alrighty. So the first step, well, we had two step ones, so let's put them both. So the first step would technically be to set variables. Set the index variables. So we're gonna say g underscore index equals 0. Actually, I think we could say s underscore index as well in the same line. They can both start at 0 for now. And then we'll say sort both, oh, hold on. Set the index variables and counter. I guess and technically result variable, result var. So we'll say set the index and result var. I'm just going to use a res, and then the next step, sort both the lists. So I believe in Python, we would say g, we would just say sorted g, sorted s. Now, would this break the time complexity? We'll have to find out, but it might. Okay, go through the list iteratively. Go through the list. I don't know how to spell that. I'm so confused. My brain is breaking, perhaps. Okay. Stay at the first child until they are given a cookie. So I think what we can do actually is we can say, since it's sorted, we can start the first child. So we can say if, or no, while, but we want to go through all the cookies. So since the cookies are sorted too, I think that so long as there are still elements in the cookie array, we can loop. So I'm going to say while s index is less than len s minus 1, we are going to say, let's just increment our s index as well, and we'll say if the child index, oops, it's supposed to be g index, if it meets the threshold, I will say, so if the cookie, so if s index is greater than or equal to the g index, then what we want to say is we want to increment the g index plus equal 1, and we want to say count res plus equal 1 as well. So basically what this is saying is that if the, let's say for in this example here, so when we're looping through, if this cookie meets the threshold or the greed factor of the child, then we're going to add 1 to the res because another child has been satisfied. So I think that might be it. I could be wrong, but let's take a look. Int object is not iterable. Okay, you know what? Let's just do, can I do this? Does that work in Python? I believe it does, but maybe it doesn't make any sense. Oh, okay, that actually worked. All right, let's try the second test case. I wasn't sure how that multiple variables on one line would work, but it seemed to do just fine. Let's do 1, 2, 3. Let's make sure that works. Oh, seems to be okay. I was about to say seems like it's taking a long time, but okay. Now let's do the test cases we did. 6, 8, 4, and then 1, 7, 9, 2. Let's see if that works. Just trying to see if all our test cases pass. Okay. I think the main problem might be if we try and use a very big list. I hope it's not too bad, but it might not be the most effective solution. Alright, let's see let's do the test thing where we need to sort. So 3, 1, 4, and 4, 4, 1. And it should return 3. Uh-oh, it did not. Okay, so we need to see this now. 2 and we expected 3, so what's the issue? Just do a quick print statement. Print G, print S. And hopefully they sorted correctly, but you might have to reassign them. Okay, maybe I didn't reassign them and I was a little bit dumb, but oops. And then S equals sorted as. Let's see now. Oh, okay. I've still done something wrong. Hmm. 1, 3, 4, and 1, 4, 4. Okay, it seems to have worked correctly. So let me go through. So while S index is okay, so S index is 0. Then we say if S index, so S0 is 1, is greater than or equal to G index. So 1 is equal to that. So we say G index plus equal 1, res equal 1, S index plus equal 1. And then we should just say the same thing until the thing is over. S index is less than, that's true. And then we say, that's strange. Why is that happening? Let's just print S index, comma G index. I want to see. Oh, that's strange. It's only giving. So it's 1 1 and then 4 3. And then where's the last iteration? Huh, that's what I'm a bit confused about. Oh yeah, I also have to make sure that it is the S index should be less than, and S index should be less than the length of G. Minus 1 as well. Oh wait, you shouldn't do minus 1. Should I just say that? So now it should work, I think. Okay. Let me make sure this test case works just with the, or let's say I have 1, 2, let's just say I have 4, for example, that only one child with 4. Say I have 1, 2, 3, 4, 5. So hopefully I get just, oh, I shouldn't get 1. Oh, I'm gonna need 0. Ah, that's no good. Okay, hold on. That's not what I'm trying to say then. So I need to, oh, I don't need this statement, I believe. Because I just need to say if G index is greater than or equal to len G, we need to break. Oops. I'm doing Java things. We need to break. And that should be, oh wait, that didn't make sense. Wait a second. Oh, sorry, the G index. No, okay. Okay. Okay, the only problem I'm worried about is that if the time complex. So, okay. I guess that worked. Alright, cool. Well, thank you for tuning into the video. So, just to recap again. So, the way I went about this solution was that I sorted both the cookie list and the child list. And then I went through and found out, so long as you're on the first child and the first child isn't satisfied, then so long as it's a sorted list, you need to deal with the first child first. And that's basically the gist of it. So you just need to deal with the first child first, and then you can move on to the second child. And then make sure you just increment your result variable, and then return that at the end. There you go, you get a solution with pretty decent stats. Now I want to see as well, what are some other stats, or what are some other solutions that people came up with? Okay, so g.sort, s.sort, result I, okay, x range. I'm not exactly sure what x range means, but it sounds pretty dang cool. Okay, again, so if I is equal to len j, break, and then, okay, if sj, okay. So it's very similar. Let's see about memory. It seems to be the same kind of general idea, general consensus. So, yeah, that's going to be it for this video. Thank you very much for watching.